The Building Management System, or BMS, is a computer-based control system. It controls and monitors some or all of the building's mechanical and electrical systems. It consists of hardware, direct digital controllers or DDCs, which apply automated control of a condition or process to the controlled system, and software, which monitors and controls the hardware systems from a dedicated PC workstation. DDC controllers are fully programmable. Program features include time schedules, set points, logic, trend logs, alarms, etc. Field devices collect signals from components of the electrical and mechanical systems under control and send those signals to DDC cabinets and outstations. There are 37 DDC outstations within the cargo terminal building, 10 in the cargo agent building, 6 in the live animal centre, and 1 each in dock security, pedestrian entry, security exit, and RTA buildings. The BMS installed in the cargo complex has been designed to control electrical and mechanical equipment so that operating conditions are maintained under normal or emergency circumstances, monitor parameters and the operating status of electrical and mechanical systems, and provide relevant reports and alarms to the user, and optimize the operation of electrical and mechanical systems to ensure comfort for the end user, the reliability of the equipment, and to save energy. The BMS monitors and controls the following components of the HVAC system: variable air volume or VAV air handling units or AHUs with or without heaters, constant air volume AHUs with or without heaters, supply, return and exhaust fans, and computer room air conditioning or CRAC. The BMS monitors and controls the following components of the electrical system: 11 kV and 415 and 220 volt switchgears, dry type transformers, 30 volt battery chargers, the uninterruptible power supply or UPS system, standby diesel generators, and transfer switches. DDC outstations communicate with each other and with BMS workstations over the IP network using BACnet and IP protocol. BMS workstations are installed in the following locations: in the cargo terminal building, Level 1, Room L119. In the cargo agent building, Level 1, Room 2011. In the live animal centre, Level 1, Room 1035. And in the SCR rooms in both RTA East and West. BMS hardware consists of a number of components: DDC cabinets, which house the power units, automation stations, and input and output units. Programming for each DDC is stored locally on the automation station. Automation stations, which are freely programmable and provide the infrastructure for the provision and processing of system and application-specific functions. Transformers, which reduce 230 volt AC from mains to a 24 volt supply, which is required by the controllers. Power supply modules, which supply power to the input and output modules. Input and output units. The input modules receive signals from field devices, while the output modules transmit signals back to the field. There are also universal modules, where each point can be individually configured as input or output. The system also comprises LON routers, which compress data from the room controllers at automation level and execute higher automation functions. And there's the operator unit, which provides the user interface with the automation stations. Field devices comprise air damper actuators, which are electronic and motor-driven. Valve actuators. Most valves are electro-hydraulic. Small valves, though, are electrical. VAV controllers, which control the volume of the air supply and extraction. FCE controllers are fitted on fan coil units and control the temperature of individual rooms. There are also a number of room sensors, which are temperature controllers, carbon monoxide monitors, humidity and temperature sensors, anti-smoking sensors, and temperature adjusters. Field devices also include differential pressure sensors, which monitor filters and control fans. Differential pressure switches, which monitor and control air filters, airflow, and fan belts. Velocity probes, which monitor the airflow rate in the air ducts. And air and liquid sensors, which measure the relative air humidity and temperature inside the air ducts and water temperature inside the pipes. For a detailed description of how to operate the individual components and systems in each building, refer to the relevant manual. The PXM20E operator unit is designed with a simple, clear display. It follows intuitive operating principles, and any settings or modifications can be followed directly on the display. Number 1 on the diagram points to the display. 2 points to the direct access keys. 3 is the alarm LED, which signals an alarm in the system. 4 points to the page up and down keys. 5 are the edit keys, which modify or confirm selected values. 6 is escape or undo or the go up key. 7 is the info key, which selects the information mode for the next keyboard click. Alarms and events received from field devices appear in the pop-up window. The alarm LED flashes when the alarm is present and changes to a steady light when all alarms have been acknowledged. An acoustic alarm is provided as an option. Alarms are written into the alarm viewer with a symbol, description, and time and date stamp. After acknowledgement, the alarm entry disappears from the alarm viewer, but remains in the history list, which will retain up to 60 entries. The scheduler allows the user to program time-dependent on and off and set point adjustments. It consists of a 7-day schedule and exception program. You can easily create, modify, delete or copy 7-day schedules using the navigation and editing keys. An individual roadmap is programmed for each day. Individual days can be omitted from the 7-day program when the exception overview field is clicked. In the 7-day program, monthly overview will appear and show the days affected by the exception. The building management system should be regularly maintained. Some components operate on lithium batteries, which have a lifespan of approximately 4 years. These are bus extension modules. The system controller will send a system event to indicate low charge, though there will be several months of battery life following this. To change the battery, remove the front cover, As long as an external power supply remains, the battery can be removed indefinitely. Routers also have lithium batteries. The status LED will flash when the battery is low. To change the battery on the router, pull down the front cover. To prevent the loss of statistical data and time and date information, always ensure the power supply is on when changing the battery.